Hello everyone. Now we'll start our demo for booking platform assessment, which includes these four features and bonus features mentioned in the assessment document. And I have used this tech stack to actually build the project. Now we'll go through the set of instructions. I'll go to my project folder, then I will go on the repository, change directory, and first run the Docker desktop. Then I will run the Docker container build. I have 5 services here: Nginx, App, Redis, MySQL, and Laravel Q. And all of my dependencies are now installing like Composer, npm supervisor. The Composer package is being installed for a project. Our container is built and run everything. Now we need to migrate. And in the terminal, then go into the container, migrate, refresh, migrate. Now come the interesting part, which is DBC. It is interesting because it is lightning fast and we have 10 million bookings sitting through our Laravel queue. And we have divided the 10 million data in 5,000 chunk per data. In every transaction, we are seeding 5,000 data, and we have also 20 million services and one admin user. And we'll actually show the interesting part. I will open Tinder, then I will show the account booking. It is slowly increasing. I think it's already half a million data now. It's not 10 million. We will see 1 million data. 10x. Let our system seed the data slowly, asynchronously. In the meantime, I will run the unit test. We have 3 unit tests here. All of them have passed. Now we will go through the API documentation of Swagger. And also we have the Postman collection given in the project directory. We import and try by yourself. We have divided the core function team within public API and the advanced function team, optional function team, admin team. First, we check the admin login. Okay, it's okay and run. So we can start our demo through Swagger. First, we will demo the public APIs, which will list the services. Let us run it. Okay, we have 20 services listed here. Copy one service from here. And we will make a booking by ID service ID. It is first execute. Okay. Encountered permission issue. booking retrieved from delete. Press again, it will retrieve from cache. The same functionality have been built in services also. It has been retrieved before from database. If we hit again, it will retrieve, I think, caching mechanism. Yes, have been implemented in service. This is our 3 public API mentioned in the assessment document. Let us point out these 3. Now we will go through the admin. First, authenticate. First we will authenticate. This is admin authentication. We copy the access token, authorize API. It's actually bearer token. Then we'll check the bookings through admin API. And here we have some other API also. I think still our parallel queue is running. Booking retrieved from database. This is a large amount of data. You can see we have 1 million or 10 lakh data. Actually, we have 10 lakh. 1, 2, 3, 4, 5, 6. If we count the number 1, 2, 3, 4, 5, 6, 7. We have 10 million, 1 million and 4 bookings. It is retrieved from database for now. It's paginated. We execute it again, it will retrieve from cache. So for fast performance, we have caching implemented here. Let us have a booking ID actually. Demo the next endpoint, which is showing the booking. Yes, we have retrieved booking service, relevant service. After that, to admin booking, go to the admin services. Yes, let us list all the services by paginated. Let us create a new service. Let's try it out. We have created a new service. We'll copy the ID in this. We will now get or show the service retrieved successfully. After that, we'll update the service. Updating the service with the ID. Let's try it out. We will put AC232. Get updated. AC repair 232 update. I want to also increase the price to 2000. Yes, we have also tell the price. Okay. We can update the data. Now I also want to delete the data now. This delete in one. Let's try it out. Service deleted successfully. So we can see We have gone through all the endpoint. Now we will try to log out. This is our last endpoint. Successfully. If I try to log out again, I will have a warning. Unauthorized access token is invalid. And this is the protected route. All the protected route has this kind of security. We are actually using JWT security. Unauthorized access token is invalid. If we log out, then we will have another message. Unauthorized access token is missing. So our demo is worked as expected, and we have also mentioned some schema for your reference. Then we will go through documentation. Now I want to discuss some of the competitive advantages of our architecture. I will not go through all of these. Scalable architecture. This is I build the architecture actually scale horizontally, so I already follow some of the microservice convention. Okay. Now it is not monolithic, as we have loosely coupled system, so we can split through microservices in future easily. And of course, this is the queue-based asynchronous processing. We have queue-based asynchronous processing in multiple parts. If we book a suppose, if we book a service here, booking, I think the service does not exist actually. To take another service like that. Okay. Booking credit service. Yes, we received the mail here. Also, we received the mail now. For the booking we have created, your booking for your service, carpentry service on Friday, May 9th of 2025, or 9th May of 2025 at 12:15 p.m. has been confirmed. Thank you for using our platform. Let's share. Okay, our mail service is working fine also, which have been done by asynchronous processing with queue. We can check it here. We have, if we actually build the booking, we should have a queue for mail send. We've sent the mail, processed. Now we check our inbox. Yes, we have received the mail. So our mail feature is also working fine. So queue helps to do asynchronous processing, so we can handle a large amount of requests by queue. Queue is already going towards the event-driven architecture, which we will implement it later. And also we have Redis cache for performance. We have tried to use Redis in all of the heavy loaded endpoint, and we have also some plan are already optimized to scale our database. For now, I will discuss about the CDR I have implemented. Of course, first we have used chunking to actually feed 1 million bookings by chunks, and our single chunk contains 5,000 data, and we have disabled the query lock. If we can actually see the file, then we can have a bird's-eye view for better understanding. Let's see our special seeder. We have used chunk. We are seeding 1 million. Okay. And 5,000 as chunk. We are dispatching every chunk to the job. We are sending it to queue to execute. First, we cache the service. First, we use the cached service. First, we use the cached service here to actually have the relationship first. Then, after getting the relational service data, we are using a loop on every for preparing every data for insertion. After insertion, we are unsetting, we are triggering the garbage collection. So I want to do the query load first. Use the cache. Now we are retrieving our data from cached service. Then if we have null, then we have to set cache. Then copy the boilerplate or directory. We'll cache it for 10 minutes. cache. Again, when the job will run again, we will get the data from cache. The cache is null. We'll retrieve from the DB from the first time and we'll set it into the cache. So second time, it does not mean need to run the cache service again. Then we have used for loop, which prepare all the chain data, and we have inserted all the data once, and we have triggered the garbage collection manually. So thus we have scaled our system. Okay. I have discussed all of them. And of course, I also can say about data integrity. As we have used DB transaction in most of the cases, so data entry, we are maintaining the data integrity. I can give an example of data integrity here. We can start the DB transaction. DB commit here, roll it back. So this will maintain data integrity, and we have advanced seeding and garbage collection, as I have said, that actually helps freeing up space to avoid performance degradation. As we can, and also our system is highly available and fault tolerant. As we have used MySQL container, we can configure it to be master slave replication. And we can set queue failover with Redis, and also mail sending asynchronous queue. You can see here, and we have rate limiting and throttling, so that no bot can overwhelm our public or admin API. We have used throttling. Admin API and public API throttling. Throttle public API by request IP 60 times within a minute. And for admin API, I also checked with the logged in admin ID and the request IP. Then I used them in throttling API. It is admin throttling, and this is public throttling. And I have some plan for future to actually scale. And of course, our code is maintained, and it has documentation and unit test. And our system is highly scalable with Redis queue, as we have optimized with cache, and we have queue in multiple services like mail sending, seeding, and this architecture is optimized for high availability, performance, and scalability. As our platform grows, this strategy will ensure that it can handle increasing traffic and data efficiently while maintaining a seamless user experience. And I have some assumptions. Admin actions are low QPS, no caching needed. Yes, our admin has few users. Admin dashboard has few users, so no caching is needed there. because there is no there is not much load, and we in public API we have some overwhelming requests, so we have implemented cache in there. And if our booking grows over time, we partition by month, archive folders with high volume workers. And for future enhancement, we have a to-do list, and I like to work with it in future. So thank you everyone and the people who will be assessing the test. For now, take care. Allah Hafiz, Adab, and bye bye.